When a system takes a representation of a capability, such as a cookie in a web server, and it decides whether to grant access to a resource, that system is performing access control. There are many different access control mechanisms possible. We're going to look at a couple of them. The first one is the simple access control provided by Unix file permissions, and then we'll look at the generalization of that into access control list. We mentioned that on Unix, once you log in, every process knows what the current user is. But every user also belongs to one or more groups, and there can be any number of groups registered in a Unix system, and every user can belong to any number of those groups. So we might draw these diagrams that show all the DB users include Alice, all the staff includes Alice, all the www admins include Alice, and so on. If I go back to my terminal, where I said, who am I could also say ID, and that is kind of like who am I, in that it tells me my user ID, but it also shows me all the groups that I belong to. ID also shows that each of these IDs is also represented by a number, and these numbers are a fixed size, so they're more suitable for use on individual files, say, but usually we think of the user and the group names in terms of these human readable names. So you can see I am in the group staff, and in everyone, and in local accounts, and all sorts of things that come by default in macOS, and also because I've installed certain applications that put me in groups as well. Another way to say this is my current user ID implies the capabilities of all these other groups as well. So when checking access to files or databases, say, I might get access because of my user ID or because my user ID is in some group where a group is given access. In general, every file on Unix has an owning user and an owning group and a table. For every file, you get to pick one user and then specify the access that that user has. You get to pick one group and specify the access that that group has, that is, every user that's in the group. And then you also get to specify what any other user who's not that user or in that group, what sort of access they have to the file. For each of these three categories, then a file can either be readable or writable or executable. These categories should look familiar from page access, and the history really goes the other way. Files originally had read, write, execute, and that turned into a strategy for memory as well. In other words, every file needs to record a user and a group and a little table like this. This table has 9 entries, but each entry is just true or false, 1 or 0, so we can represent that as 9 bits. And the 9 bits are often written out in these different ways. So when you do an ls, you may see these bits reported in groups of 3 like this. This is the same order as reading across the table here. And where there's a 1 in the read column, an R is written. Where there's a 1 in the write column, a W is written. And where there's a 0 in, say, the right column here, a dash is written instead of a W. Equivalently, we could write this in binary notation like this, with 1s, where read, write, and execute are available. And then you may also see it written in numbers like this. The leading 0 here in C and some other context indicates an octal number instead of a decimal number. So this is not 750. This is 0, and then 5 times 8, and then 7 times 64. But the reason this octal encoding is convenient is because each digit in octal represents 3 bits. So this is the others permissions, the group permission, and the user permission here. So the user 7 means read, write, and execute. The group is read and execute, and everyone else is no permissions. The meaning of read, write, and execute should be clear from a file. You might be able to read the file without actually being able to run it as a program. These same bits apply to directories where read permission corresponds to the ability to list all the files and access individual files in that directory. Write corresponds to the ability to create a new file or subdirectory within that directory. And execute refers to the ability to make that directory the current directory. It's not really that often that you want a difference between read and execute for directories, but it is there and has some uses.